Okay, so let us start the second part.
You have the relationship.
Okay, so let us start the next part. Thank you. Okay, now the question is that what happens if delta has the other scenario? What is the other scenario? If it is positive, I have two solutions. I am more or less done. I mean, completely done with defining the general solution. But the problem happens that if delta becomes 0 sometimes, still I will get one solution, because if delta is 0, what happens? This is completely gone. If delta is 0, then it means that R1 and R2 are both equal to the same number now, which is what?
0.
Okay, so if delta is indeed 0, that's what we happens. Okay, but the problem is that one solution is found. Okay, I still can write e to power rx. R is this number. Is one solution. But the problem is that the problem is not fully solved, because still I need to. So I can write, for example, I can write y equals to a constant e to power rx is also a solution. But I hope that you agree this is still not the general solution, because it contains one free parameter. But this is second order differential equation, so I need two free parameters. Okay, because we are not doing this in a correct way. There is some techniques in differential equations tells you how to discover the second one if you know one of them. Okay? But I have to tell you what the answer is, but of course we can convince ourselves that what I'm telling you is not a lie, it's correct. Okay? The point is that if this happens, one of them is this one. Oh, sorry. By the way, I am used to x, unfortunately. So if you don't mind, because I have done all my calculation is x, so let me violate myself a little bit. So I am taking x, so yeah, because that would be very hard if I want to change all x's to t. Okay, so e to power rx is actually one solution. My claim is that if you take this one and multiply it by x, it will be another one. Okay, so at this level, you need to wait for me to tell you, and then if you want, you can check if I am telling you the truth or not. So, and then if I can convince you this is also a solution, then can you tell me what will be the general solution then? I will take the first one multiplied by any constant that I like. I multiply the second one by any constant that I like, according to what we proved for any differential equation linear with constant coefficients. This will be the general solution. So this is something that you have to remember. In the case that you get only one answer, you don't have the problem with finding the first one, but for the second one, you have to remember you have to multiply by an extra x. Okay, so but if you want to just believe in it, it's not very good idea. Let us prove it. Okay, so what I want to prove that under this condition, this is indeed a solution to this differential equation. So let me write it here for you, and I want to confirm that under this condition, this will fit this equation. Okay, if I want to do that, I have to put them here. So y prime is the product rule, so it becomes e to power x plus this one multiplied by the derivative of that one, which will be rx e to power rx. And I need another derivative, so y double prime becomes the derivative of this one, which is r e to power rx. This one is a product rule, so it becomes r e to power rx plus r squared x. So you see, this is a product rule, so it becomes the derivative of x, which is 1 times the second one, plus rx multiplied by the derivative of this one, which brings another r here, and then I will put it. Is that right? Okay, so let us plug these into this equation. So the left hand side becomes equal a times this expression, and by the way, you see that they are the same, so it becomes 2r e to power rx. I multiply it by a, so it becomes 2ar e to power rx. And there is another one, I have to multiply it by a, so it becomes arx e to power rx. This is the first one. And then this is prime. And I have to multiply b by y prime. So it becomes b e to power rx plus b rx e to power rx. So I did that one. Then I have to multiply this y by c.
There in the second derivative in y, you have, I think, a 2x squared somewhere.
Further?
To your right side,
Yes.
there's like a 2, okay,
This is r2.
R2.
Yes. I am missing that too, yes?
So it needs to go down also.
Okay, so if I multiply this by a, this is correct. So this is r2. Yes, thank you very much. Thank you. It seems right, yes? But now what I can factor out, what? Between this one and this one and this one, I can factor x and e to power rx out. From here, ar squared is left. From here, br is left. And from here, c is left. Yes? But between these two, I can only factor e to power rx out. So this becomes 2ar, and this becomes plus b. Yes? But you can immediately tell me what this is. What is that? This is so it is equal to 0 because I solved that. But this one, do you think this is also 0? Yes, because r in this scenario, I can write it as 2a r is equal to minus b. So 2ar plus b is also 0. Yes?
Yes.
This means that this is equal to 0.
Okay.
So this is mathematically correct. But the point is that how could I guess that 1 multiplying by x will work? Because I know some other theorems. Okay? But at least you know that if you find one of them, you multiply that one you found by 1x, it will be a new solution. And this is the proof that I am telling the truth. Any questions? Okay, so this is something that you have to remember. That if delta is 0, from the characteristic equation you get only one answer, but you need two. You need to remember that the second one is just the first one multiplied by single x. And this will give you the general solution. Is that right? But the hardest one to remember is probably the third scenario. What is the third scenario? Delta is negative. If delta is negative, then you have two complex roots.
Yeah.
Okay? So this means that R1 and R2
Are not real.
will be minus b plus or minus a square root of b squared minus 4ac divided by 2a. But b squared minus 4ac is negative. So if you don't mind, to make it positive, let me factor a minus sign out. So what happens? It becomes minus b plus or minus. Let me write it this way for you. So it becomes minus, and then it will be 4ac minus b squared over 2a. Okay, but this will be minus b over 2a, and this will be plus or minus. Yes, this expression is a square root of minus delta, because this is no longer delta, it is opposite of delta. And then I have over 2a, but about the square root of minus 1, which is involved, I will have 1i here. Is that right? So you see, I am writing the same expression. Here I factor the minus sign out, so I have to flip. This is no longer delta because delta is b squared minus 4ac, so this expression is minus delta. Okay? But there is another minus sign here, which means the square root of minus 1, which is the complex number I, and this is what I have. Is that correct? And usually, according to the notation in the course book, this is called K, this is called omega. Okay? I'm using the notation in the book. I prefer to write alpha and beta, but this is what the book is written. Okay, but what are the solutions? The solutions are a little bit mysterious. One solution will be exponential to power kt multiplied by cosine omega t. The other solution will be e to power kt sine omega t. The proof is more or less like this. Sorry, again I am mixing t and x again. So let me write everything in one x now. So x, 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 x. Okay? So if you want, so of course I have to prove this claim, but the proof is a little bit more complicated than that, but it will be along these lines. So you just put them into equation and try to see if you can prove it or not. Okay, so then it means that what is the general solution? The general solution will be one of them multiplied by one constant. Yes, plus the other one multiplied by another constant. So you have to remember. Okay, sometimes in some books they factor e to power rx out. This is also good. It doesn't matter how you write it. In some books you see that they factor this part out and they write it in this form. That's also good. Okay? And we don't have time, otherwise I could confirm that each one of them is indeed a solution. So be careful. K and omega are always the real numbers. I is just split up. Okay? So more or less the problem of this is finished. So whenever you have this type of differential equations, second order, homogeneous with constant coefficients and linear, it's very simple. You find the characteristic equation, solve it depending on which situation happens. You have to have the formulas in mind and write it down. Is that right? So let us solve 3 examples immediately. So if we go to example number 8, and if you go up there, you see that I have written everything in terms of t. Sorry for this mess. From now on, if you don't mind, let me write everything in terms of t, because I also sometimes confuse myself. So example 8, number 1. Example 8, number 1, we want to find the general solution of this differential equation. Okay? So, what we learned now works for this case. Why? Because it is linear, it is second order, and it is with constant coefficients, and on the right hand side I have homogeneous, it is 0. Is everything right? So, what do you do first? You immediately write the characteristic equation. And that is extremely simple. The only thing that you have to remember, instead of y double prime you put r squared, instead of y prime you put r, and instead of y you put 1. If you just want to think it in that way. But that's the proof. So I would write the characteristic equation is r squared plus 5 what? 5r plus 6 equals to 0. And that is extremely simple. You use PQ or ABC formula. If you don't mind, let me skip, because you can also factorize. It doesn't matter how you solve it. So can you factorize it? R, so I need 2 numbers with this sum.
Plus 5.
Plus 3. Yes? So it doesn't matter how you solve it, but this was faster. So I get 2 answers, -2 or r equals to -3. So this is the first scenario. That is the simplest possible scenario. But you have to remember the formula. So what can I write for my general solution? I write a capital or any constant, a that you like, e to the power of the first one. Yes, because I promised you to work with t, let me work with t. Okay? And then plus
B.
That's very simple. Yes? Let us go to the next one immediately. The next one of the same exercise. We want to solve this one. Again, what do? We write the characteristic equation. But this is even simpler. You can use PQ or whatever. But there is only how many solutions? Because this is a completed square. So how many solutions you get? Only one. It's a double root, but this is the same. This you have to use your memory, okay? So one solution is still what? This is one solution. R is this number. But here you need to remember what was the second solution. What was it? This solution multiplied by an extra t. Or if your variable is x, by an extra x. But you need to write the general solution. So it is constant multiplied by that, plus probably another constant multiplied by that. You can write it like this, or if you want, you can factor it out and write it a little bit more clean, yes?
Why the extra t?
Yeah, I just proved it here for you. This is something you have to remember. When delta is 0, which is in this case you get one solution, one result is the same as before, but I proved for you that if you multiply that by one extra x, it will give you another one. But after proving it, then I send it to my memory and use it all the time.
Okay.
Is that clear?
Where does the cosine and the sine come from?
Yes, because in principle, if you want to do it properly, then you will get two answers, yes? Because one R1 will be k minus omega I. The other one will be R2 k plus omega I. Okay? And then, what is the first solution? It is R1x, that you put this one, for example, which will be e to the power of k minus omega I. Yes? And then times x. Then it becomes e to power kx minus omega xi. And then you can write it as e to power kx times e to power minus omega xi. But if you remember, in complex numbers, we have this Euler formula, that e to the power of I theta can be written as cosine theta plus I sine theta. So somehow sine and cosine are coming from the Euler formula and the complex numbers. So in principle, I don't want you get involved with complex numbers, because if you can work with complex numbers, part 1 and part 2 are more or less the same. Because in part 1, I have two solutions, but both of them are real. In the last one, still I have two solutions, but both of them are complex. If I want to use the same method for part 1, I need to know extra formulas for complex numbers. Then you see that cosine and sine will come into the game. But the point is that if I want to work with complex numbers, the coefficients will remain complex. But because I am working with real numbers, I want to have my solutions in the world of real numbers. Then I have to learn how to get rid of complex coefficients. If you do all of these things, cosine and sine will appear in this form. But this is one way to understand where sine and cosine are coming from, if you want to understand it. Otherwise, you just put it in the equation. You have to trust me that I am giving you the truth. And then you take it with you and put it in the equation. And using these formulas that I have written here for you, you can confirm, exactly as I did in this case, that this is indeed a solution. Yes? Okay. So this is the second one. Let me solve one more from the last type, and then we more or less one thing is left, which is the hardest part. We have to go through it. Okay, if I want to solve the last one in this example, y double prime plus y prime plus y equals to 0. So I want to find that. Again, I write the characteristic equation, r squared plus r plus 1 equals to 0. But then I have to use PQ or ABC formula. I prefer ABC all the time. So it is minus b plus or minus the square root of this one to power 2 minus 4 divided by 2. So this becomes minus 1 plus or minus a square root of minus 3 divided by 2, but the square root of minus 3 can be written as what? I square root of 3 divided by 2. So it becomes minus 1/2 plus or minus a square root of 3 over 2 times I. Please tell me, is the calculation understandable?
Yes.
Yes? So what, for example, square root of minus 3 can be viewed as 3 times the square root of minus 1. But this one is I. Is that clear?
Yeah.
So now I have to have the formula in my head. This number is K. This number, be careful, the positive one,
Omega.
is omega. And then the formula is there. So y becomes A e to power k times t multiplied by cosine omega times t plus another constant b e to power the same k sine the same omega. This is one way to write it, or some people prefer to factor e to power minus a half t out, then it becomes this.
Is the t inside of the sine and the cosine?
Yes, yes. Yes, yes. If I have been careless, so let me write it for you. Because usually when you write this, it means that is there. So usually you don't need to write pair of brackets. You see in the books they write this, but they always mean this. Yes? Yes.
The workshop also includes heterogeneous
Yeah.
versions of the same equations. Do we just guess solutions for those, or?
Yes, mainly there is another method that you don't need to guess somehow, but it needs heavy integration. And even if you know those methods, the method that I'm going to teach you, and this is in this module, which is called the method of undetermined coefficients, for those cases it works, it is much more efficient than the other more advanced methods. Yes, that's why it's good to know it. So even if you know the advanced methods, but still this method that we are going to teach now is actually good. Good to know. Okay, so any questions regarding this problem? Just we want to improve increase the level one more step and thinking about non-homogeneous ones. So what happens now, I want to understand about this differential equation. The left-hand side is exactly the same, but the right-hand side is a function of t. So I will stick to the variable t from now on, hopefully. If I mistake, please let me know. This is the non-homogeneous one, okay? There is a theorem that I don't want to prove it. If we have time, we can come back to it. If you want to find the general solution of this, what you need to do, you need to break it into two parts. One, the homogeneous one that we learned how to do and find the general solution for it. Let us pretend that this is found, and I put an index here for the homogeneous one. And go back to this equation, not try to find the general one. Want to find one particular one. Any one, even if you can guess. And there is a theorem that guarantees that if you add them up, this will be the general solution that you are looking for. Okay, let us take this for granted now. If we have time and if you are interested, we can come back and prove it. The proof is very simple. The videos that I have put for you, I have shown I have given the proof there. Okay, so let me just explain it again. So far, we learned if this one is given to you, and you are supposed to find the general solution. One thing that you need to know is that you break your problem into two problems. First of all, pretend that the right-hand side is 0 and solve it as we learned. That one, when it is found, put it here, which is the y of the homogeneous one. But then, again, go back to the original problem. This time, not try to find the most general solution. Try to find one solution that works. That is called a particular solution of the non-homogeneous one. there is a theorem that guarantees if you add them up, it gives you the general solution of what you want. For the time being, take it for granted, let us understand it, okay? So, which one is a problem now for me? Because this we learn how to find for the homogeneous one. So, but this one is something we need to know how to find, a particular solution. Is that clear? For the particular solution, there are some general methods in general for any f, okay? But this is not part of your module today. You only can solve this problem for some very specific form of f of t, okay? Those f of t's that we are interested in are the ones that we can somehow have an educated guess for the form of the solution. Okay. One of those cases, for example, if I give you f of t is 2t plus 5, for example, a very simple case for f of t. So for example, if you want to guess a solution for the differential equation so that the right hand side is 2t plus 5, do you even imagine exponential functions? No, because you know that if I put an exponential function on the left, after doing all these calculations, it remains exponential. So it cannot fit to a polynomial. So is it a good idea to put logarithmic function here? No sense. Trigonometric functions here? No sense. The only type of function that might make sense for this case is what? Is a polynomial. Because if I guess a polynomial, if I have a polynomial, when I put it here, it remains a polynomial. If I differentiate the polynomial, it remains a polynomial. 1 multiplied by b is still polynomial. This is also polynomial. So it means that the left-hand side will be polynomial. The right-hand side is also polynomial. I have some chance to make them work, to make it work, yes? So I will never start with guessing exponential functions. Okay, but then the question is this. How many polynomials functions are there? Infinitely many. So which degree is relevant, do you think? For example, do you think it's a good idea to guess a polynomial of degree 10?
No.
No, because if that polynomial that I guess is of degree 10, this will be of degree 10, this will be of degree 9, this will be of degree 8. The left-hand side will be finally a polynomial of degree 10, and I know that I have only a polynomial of degree 1 on the other side. Is that right? So this means that what is the best guess? So let me give you, by the way, an equation to solve it, for example, together. Let me pick one of these equations. So, for example, let me put this equation to teach you how to think. So y double prime plus 5y prime plus 6y. Instead of putting equal to 0, let me put 2t plus 5 on the right, and I want you to find the general solution of this equation. So what I told you, if you see this in the exam, the first thing you do is to write the homogeneous one, yes, and use what I told you there on the first part of that word. So you continue like that, and you find YH, which we did. What was it? It was here. It was here. Yes. So it becomes A e to power minus 2t plus b e to power minus 3t. Yes? So if this is given in the exam, the first thing you do, you write the homogeneous one. In these dots means this. You write it and you find it. And you call it Weissowitsch. But now, my question is that what is y particular for this one? So we have some educated guess now. That what is the good chance for yp to be a polynomial of which degree?
First degree.
Yes, first degree. Yes, it's a good choice. So let me put it like this. So if you don't mind, I don't want to get confused with alpha. Let me write alpha and beta. It doesn't matter. This method that I am teaching you is called the method of undetermined coefficients. It includes an educated guess. This is an educated guess. It's not a very random guess because I am just picking polynomials. So it's an educated guess. but still it contains some undetermined coefficients, so that I have to use this analytic work to determine them. How should I determine it? By putting it back to your original equation. In order to put it back in my original equation, I need to take the derivative, I need to take two derivatives. So let us do it together. So y prime p becomes what? Alpha, and y double prime p becomes what? 0. Yes? And then let me put back everything into my original equation. This is 0 plus 5 alpha plus 6 times alpha t plus beta equals to 2t plus 5. Yes? And arrange the left hand side. What do I mean? 0 is 0, so 5 alpha plus 6 alpha t plus 6 beta is supposed to be equal to this. Let me arrange them. There is a t involved here. I write it separately. There are no t's here. I combine them together. Yes? I want to fine-tune alpha and beta so that the left-hand side matches with the right-hand side. So how can I match them? It is enough to make 6 alpha to be 2, if I can make it. And if I can make this one to be 5, I am done. The left-hand side matches with the right-hand side, yes?
Yeah.
But this is a very simple system to solve. From here, alpha is 1/3. And I put it here and solve for beta. So this becomes 5/3 plus 6 beta is equal to 5. I move it to the other side, so 6 beta becomes 10/3, and I divide by 6, 10/18, so it is 5/9. Okay? Now I know what alpha is, I know what beta is, so it means I know my particular solution as well. I plug them back. So y particular becomes what? Alpha, which is 1/3, times t plus beta, 5/9. Okay? Before just continuing, let me tell you something. Even though I am doing some guesswork, but it was, I hope that you agree with me, it was not easy at all to guess these two numbers. Okay? So this method of undetermined coefficients is a combination of educated guess and analytic work. Okay? So we are deriving something. It's not just that we are guessing everything. Okay? So we found that. But the bottom line is that I need to write the general solution of my differential equation. So what should I need to use this theorem. So what you need to write at the end is that y is equal to yh, which is this one, plus b e to power minus 3, plus the particular solution that you found. So this is the method of undetermined coefficient. So the first thing you do, you should have an educated guess. In your educated guess, there will be some unknown coefficients, which are called undetermined coefficients for the method. By plugging that educated guess back into your original, you determine the unknowns, and then you have your particular solution, and then you use this theorem. That's more or less everything. But there are some subtleties, of course, we have a little bit of time we can describe. Okay? So now my question for you is that we learned that this method of undetermined coefficient works for somehow polynomials. If I have only polynomials on the right-hand side, my educated guess should also be of the type of polynomial. What other functions do you think this method is suitable for? Polynomial functions are more or less good candidates for having on the right. Can you guess another type of function on the right-hand side? So that what?
Trigonometric.
Okay, which type of trigonometry? For example, if I have tangent x or something on the other side, yeah, sine and cosine. Do you know why? Because the derivative of sine becomes cosine, the derivative of cosine goes back to sine. So somehow. So if I have a combination of sine and cosine in some way, it might be useful. This is the second category. The first category, polynomials. The second category, a combination of sine and cosine functions. There will be another category as well. Exponential. Just learn. Because if I have exponential, what is your educated guess? Exponential. Is that right? So these are the three main parts that this method of undetermined coefficients is supposed to be useful to work. Okay? So there are many examples I have written here, but let me choose one of them and let us go through these problems. So there are some things that we can skip. I have written it down there. But let me start with some example 10. Example 10, let us do question number 2. Okay? So, example 10, question 2 is this equation. Y double prime minus y prime plus y is equal to 2 sine 3t. Okay? Because we don't have time, and this one is easy hopefully for you, because it's always a standard, you don't need to think. You always follow the same rule. So if you don't mind, let us try only, in that example you have to find the general solution for the whole problem. But hopefully you know how to find y sub h by the method we described. There is nothing surprising you there. So let us just concentrate on finding y sub p. Because if you know that, then you will add them up, you will have your answer. But now, look, the right hand side, I have this function. If you want to have an educated guess, what type of guess do you write? That's what I want to rely on your intuition a little bit. So what guess do you think is a good one here? Trigonometric. For example, do you think it's a good candidate?
Maybe with b cosine t.
No, just this one. Is it a good candidate?
Maybe 3t.
No.
3t should be. Because there is no way I can construct 3t by just writing t. So at least for the first educated guess, let me write this 3t.
But then the cosine would.
Yes, but then the problem is that when I take one derivative, cosine comes into the game. So I have to give this chance so that I can calculate. So there is no guarantee that it's only sine function. Okay, so whenever you have sine only or cosine only or a combination of sine and cosine with the same arguments, this is the educated guess you need to write. So don't say that, okay, I have only sine, I will write sine. I have only cosine, I will write cosine. Even if you have one of them, you write both of them. Okay, so let us see if it works or not. So what I need to do, I need to calculate the derivative, which becomes 3a cosine 3t minus 3b sine 3t. And then I need to do one more derivative. So this becomes minus 9a sine 3t. And then it becomes minus 9b cosine 3t. Do you agree? So these are my derivatives. Now I take them with me and put them back into my equation. So it becomes minus 9a sine 3t minus 9b cosine 3t. And then I have minus y prime. So I multiply everything by minus sign. Then it becomes plus 3b sine 3t. And then I have plus y. This is my y. Okay, so this is the left-hand side after my educated guess. It is supposed to be equal to the right-hand side. Yes? But then hopefully you know what to do. There are sine and cosines involved. I want to get rid of cosines, but I want to adjust the coefficients so that the right coefficient appears. Okay, so what is the next thing we do? You see, I have a sine 3t here, I have a sine 3t here, and I have a sine 3t there. So let me simplify them as much as I can. This coefficient is a, this coefficient is minus 9a, so it becomes minus 8a, and this one is 3b. If you don't mind, let me factor sine 3t out, make it simpler. So I consider these three terms. There are three more terms involved. All of them has cosine 3t. So let me factor cosine 3t out. But be careful, this is minus 9b, this is plus b, so it becomes minus 8b. And then I have a minus 3a. You agree? It's just simple algebra. And then the right hand side is supposed to be equal to 2 sine 3t. And by the way, the logic is that you just need one solution that works. You don't need the best solution. So here, guessing hopefully is much simpler. Why? Because I want to force the left hand side matches with the right hand side. How can I do that? By putting this by hand equal to 2 to fix that 2, and put this one equal to 0 to get rid of sign. And then this will be able to do, we will be able to do it, yes? So it means that I will make a system, and then the other one, minus 3a equals to 0, and because we don't have time, as usual, so you continue and find a and b. And when you found them, put them back here, you will have your particular solution. And then put the homogeneous one, find the complete one, and then add them up. Okay? Any questions? But there is one more subtlety that is a little bit tricky. I hope that I have some examples here. Yes, let me solve number 4 because I want to describe a little bit of subtlety here, but you have to read the book and the notes to master everything here. So number 4 is this one. This one I want to solve from scratch. I think I did it at some point. Oh yes, it's here, good. The right hand side is equal to... I have to switch the camera view. Okay, so now this one is t e to power 2t. Okay, so hopefully if you listen to this one, this is a little bit subtlety. Okay, so first of all, on the right hand side I'll have a product of an exponential and a polynomial. And then whenever this happens, in principle, your educated guess should be a polynomial multiplied by an exponential. It is very weird, but it works. Okay? So if I have only this t, what is your educated guess according to what we learned? Polynomial of which degree? 1. If you have e to power 2t alone, we didn't solve any example of that type, but it is not hard to guess. What will be your educated guess? Exponential to power 2t. So if you have this one alone, your guess is at plus b. If this is alone, your guess is a e to power 2t. Okay? So what I am telling you, here you have the product of them. If you have the product of them, the educated guess will be the product of them. Okay? You need to understand that. But when you multiply them, so don't write them with a lot of coefficients. So the educated guess should be in principle this one. Okay? So this one alone, this is your educated guess. This one alone, this is your educated guess. And I am telling you, if you have the product, just multiply them. But when you multiply them, this a goes here, it becomes a squared. This becomes ab. So a squared, you can call it a. ab, you can call it b. So again, you have two constants. So a polynomial of degree 1 multiplied by an exponential function. Yes? But this is not the only subtlety. Here, there will be another subtlety that if you put this here, it will not work. There is no time to tell you that. You take this one with you and put it here. You will see that everything vanishes. I mean, the coefficients that you are looking for vanishes from the equation. And then you cannot find them. So I want to tell you what is the source of this problem. Because it will save you a lot of time. Because if you want to learn, okay, I will do it, and if it doesn't work, I will do something else. It takes a lot of time. So what you do, you exactly as before, you are doing it with the homogeneous one. but fortunately I have it on the board. It becomes, the answer is this. So let me open it up. The answer is this. It's a e to power, this is minus. If this is minus, there is only one difference. This will be minus, so it will be plus. Okay? So, sorry for that. This becomes 2t plus bt e to power 2t. Okay? This is the YH. But now, as I told you, in the normal circumstances, this should be your educated guess. Let me write alpha and beta, not to get confused with this. So you see, this one polynomial, this one exponential, they are multiplied. You have to accept what I'm saying. You get multiplied. Most of the case, the product will work, but not in this case. Why is that? Because if you multiply this, if you open it up, it becomes alpha t e to power 2t and beta e to power 2t. Okay? And then you see that this one appears here. This one also appears here. So this, if you put this back into this equation, because it will fit this equation, these will be cancelled and there is nothing you can find. What is the solution? The solution is a little bit subtle. If this happens, you multiply by an extra t, your educated guess. If you multiply by an extra t, this will be t squared, this will be t. But that is not good enough, because t e to power 2t also appears here. So then you have to multiply by t squared. Yes? So let me explain this again. Okay, so might be you're confused. So you see, just give me 5 minutes to explain it. Okay, so e to the power of 2t. If I have the product, if this is alone, this is my educated guess. If this is alone, this is my educated guess. But if I have the product, I want you to learn that in principle, you just multiply them, okay, with one good coefficient. This is usually the case, but it will not work here because when you open it up, there will be two solutions, t e to power 2t and 1 e to power 2t. And this one is a solution for the homogeneous one. This one also is a solution for the homogeneous one. If this happens, you have to multiply by extra power of t. And that extra power is at most 2. You first multiply by 1t. If you multiply this by 1t, this becomes t squared. This becomes t e to power 2t. This is fine because it does not appear here, but this one appears here. So it means that t was not enough. You have to multiply by t squared. So this becomes t cubed and this becomes t squared. So this means that the educated guess here will be t squared at plus b times e to power 2t. This should be your educated guess. Okay? And you might say, okay, Bob, what happens if t2 doesn't work? No, there is a theorem that guarantees that this number that you multiply is at most 2, because that's a second degree equation. Is that clear what I told you? You can, of course, ask your TA, because there is no time for it. For example, let me ask you one more question. If I have this one, can you tell me what will be your educated guess?
Some e to the 2t.
The standard guess is, because this is exponential, your standard guess should be a e to power 2t. But in this case it does not work. Why? Because this function is one of the solutions of the homogeneous one. Whenever this happens, the solution is simple. Multiply by t or at most t squared to see which one works. You will start with the lower one. You multiply your educated guess by extra t. Do you think that this works? Does it work? No, because t e to power 2t is also a solution still for your homogeneous one. Yes? Is that right? So you multiply by 1 more t. Is that enough now? Yes. Because t squared e to power t, 2t, is not one of these solutions. So your educated guess for this should be this one. To understand it fully, let us go home and take it like this to see what happens. You will see what happens. You will not be able to find a, because a will be eliminated from the equation. Okay? So this is, you will not learn it until you really do it. So that is the only subtlety that you have to be careful when it comes to method of undetermined coefficients. That educated guess, the terms, none of the terms in the educated guess should be a solution to the homogeneous one. If it is, multiply by t and check it again. If it is still one of them a solution, multiply by t squared. Mathematicians guarantee that you don't need more than t squared. Is that clear? But you have to learn. I have put a lot of these type of questions in the lecture notes. So if you don't understand them, you can work it out and see what happens. Okay? But I will just tell you, just put it to see what happens. If you're educated guess, you don't care about this t squared, put it in the equation, you see that you are looking for a, but a is gone from the equation. So you will not be able to find it. Is that understandable? Okay, thank you very much. Thank you.